Welcome to the DIY Honda Garage channel. This presentation focuses on the DTC P050D, which signals a cold start idle speed problem specifically for the 2016 to 2022 Honda Pilot. The DTC, or Diagnostic Trouble Code, indicates issues related to the control of idle speed during cold engine starts. Understanding this error code is crucial for identifying potential performance issues that could lead to rough starts or abnormal idle behavior. The P050D code falls under the Powertrain Control Module (PCM) diagnostic category and may trigger the check engine light, alerting drivers to check their vehicle's health. Proper diagnostics using tools like the HDS Honda Diagnostic System is essential to pinpoint the exact issue, as it could relate to various components within the intake air system. Throughout this presentation, we will break down the error description, possible causes, and detailed troubleshooting steps to effectively address this diagnostic code. DTC P050D signifies a cold start idle speed issue, primarily involving the Powertrain Control Module, PCM, which regulates engine performance, including idle speed. When the vehicle starts during cold conditions, the PCM monitors various sensors, adjusting the fuel-air mix for optimal engine performance. Sensors like the engine coolant temperature, ECT sensor, and the mass airflow, MAF sensor, are critical in determining how the engine should behave at startup. The PCM's analysis of data from these components ensures a smooth cold start by managing the air-fuel mixture to prevent stalling or excessive idling. In terms of location, the PCM is generally found beneath the dashboard, while the ECT sensor is located near the engine block. Proper identification of the cold start system components is crucial for effective troubleshooting. Several potential causes can lead to a P050D error code. A faulty mass airflow (MAF) sensor or intake air temperature (IAT) sensor can disrupt the air measurement accuracy, affecting the PCM's decision-making. If the ECT sensor provides incorrect readings due to wiring damage or sensor malfunction, it can mislead the PCM regarding engine temperature, leading to idle speed issues. Physical blockages or vulnerabilities in the intake air ducts can hinder airflow, impacting the engine's performance during a cold start. Lastly, a defective throttle body can interrupt the airflow path, necessitating inspection for dirt, carbon deposits, or physical damage. Diagnosing these components promptly is essential to rectify the cold start idle problems effectively. Several symptoms may indicate a P050D error code. Drivers may notice a rough idle when the engine starts from cold, characterized by fluctuations in engine speed and stability. The check engine light may also illuminate, prompting the need for a diagnostic evaluation. Inconsistent engine performance can manifest during initial acceleration, where the vehicle may stall or hesitate, affecting overall drivability. Monitoring these symptoms is crucial, as they can evolve into larger performance issues if left unaddressed. Additionally, fuel efficiency may decrease as the PCM struggles to maintain the appropriate air-fuel mixture. Being aware of these symptoms assists in diagnosing the problem early and implementing necessary repairs before they escalate. The first troubleshooting step for DTC P050D involves performing a powertrain generation management fuel injection (PGM-FI) system check. Begin by turning the vehicle to the on mode, ensuring all electrical systems are powered without starting the engine. Utilize the HDS Honda Diagnostic System to check for any pending or confirmed DTCs apart from P050D. If additional DTCs are indicated, these should be addressed first, as they may provide insight into underlying issues. If no other DTCs are present, proceed to the next step in the diagnostic process. This initial check is vital, as it lays the groundwork for understanding whether the P050D code stands alone or correlates with other issues affecting vehicle performance. The second troubleshooting step requires a visual inspection of the intake air duct. Begin this step by turning the vehicle to the off, lock mode, to ensure safety while handling components. Carefully examine the intake air duct for poor connections or any blockages that may inhibit airflow to the engine. It's essential to check the fittings and clamps that secure the duct, as leaks can result in incorrect airflow readings. If any issues are found, reconnect or repair the air duct as necessary. A well-functioning intake air duct is critical for accurate air measurement and ensuring the engine receives the correct air supply during cold starts. Once the inspection is complete and the duct is confirmed to be in good condition, advance to the subsequent steps in the troubleshooting process. In this third step, the focus shifts to the air cleaner housing. This component plays a pivotal role in filtering the air entering the engine, which directly influences performance and efficiency. Carefully inspect the housing for any poor connections, loose clamps, or blockages that may introduce unfiltered air into the system. Ensure that it is adequately sealed to prevent leaks, as even a slight breach can disrupt the air-fuel relationship managed by the PCM. If blockage or damage is identified during the inspection, proceed to replace the air cleaner housing as required. This step is vital for optimal functioning, since a clean airflow is critical for cold start performance and overall engine health. The fourth troubleshooting step involves examining the air cleaner element itself. This filter is responsible for trapping dirt and debris from the incoming air, ensuring only clean air enters the engine. Start by removing the air cleaner element and thoroughly inspect it for signs of dirt or blockage. If the element is found to be excessively dirty or clogged, replacing it is necessary to restore optimal airflow. A compromised air cleaner element can hinder engine performance, particularly during cold starts, as it directly affects the air mixture available for combustion. Regularly checking and maintaining the air cleaner element is essential for the longevity and efficiency of the vehicle's engine. The fifth troubleshooting step focuses on problem verification, particularly concerning the engine coolant temperature, ECT sensor. Begin by allowing the engine to cool until the ECT sensor 1 registers a temperature of 122 degrees Fahrenheit, 50 degrees Celsius or less. Utilizing the HDS, clear any existing DTCs before starting the engine. Once started, let it idle for a minimum of 10 seconds. During this idle period, monitor the OBD status for DTC P050D using the HDS. If the HDS indicates a failure, this confirms that the problem has been duplicated. Conversely, if it indicates a past status and cannot replicate the issue intermittently, it suggests the system is functionally sound at this time. This troubleshooting step is essential to confirm if the error persists or if it was a one-time incident. In the sixth troubleshooting step, we perform a MAF sensor performance check. Start the engine and maintain the engine speed at 3,000 RPM for a duration until the radiator fan activates. Then, allow it to return to idle. While holding the engine at 2,500 RPM for 30 seconds, check relevant parameters using the HDS. Specifically, monitor the MAF sensor's readings, which should fall between defined thresholds for the vehicle configuration. Ideal readings for a 9-speed automatic transmission should be between 9.4 and 13.2 grams per second, and for a 6-speed automatic transmission, between 9.2 and 13.0 grams per second. If the current values align with these thresholds, It indicates that the MAF sensor is functioning correctly, allowing you to progress to the next troubleshooting step. If discrepancies are noted, immediate replacement of the MAF sensor/IAT sensor is necessary. The final troubleshooting step evaluates the performance of the IAT sensor. Begin by turning off the vehicle and allowing the engine to cool to ambient temperature. Once cooled, record the ambient temperature for reference. Start the vehicle again and quickly note the IAT sensor 1 value from the HDS data list. Comparing the observed reading of the IAT sensor with the previously noted ambient temperature is crucial. If a difference of 5.4 degrees Fahrenheit, 3 degrees Celsius, or more exists, it indicates a faulty IAT sensor, necessitating its replacement along with the MAF sensor, as they often work in conjunction. If no significant difference is acknowledged, it suggests the IAT sensor is functioning as intended. However, ensure to check for any dirt, carbon buildup, or damage within the throttle bore, as cleaning or replacing the throttle body may be needed depending on the assessment. After completing the necessary repairs for DTC P050D, a final verification phase must be performed. Use the HDS to confirm that all DTCs have been resolved, ensuring that the P050D and any other associated codes have been cleared. Following this, a test drive of the vehicle is crucial to validate that the engine starts smoothly and maintains a stable idle, particularly during cold starts. During the test drive, pay close attention to symptoms such as idle stability and engine response under various conditions. After the drive, continue monitoring for recurring issues or any new codes that may indicate underlying problems. This step is essential for ensuring confidence in the durability of the repairs and the reliability of the vehicle's performance in subsequent cold starts. Preventive maintenance is a pivotal aspect of avoiding DTC P050D in the future. Regular inspections of air filters, particularly the air cleaner element, can prevent dirt buildup and maintain optimal airflow to the engine. It's advisable to replace the air cleaner element as part of routine vehicle servicing based on manufacturer recommendations. Additionally, frequently checking sensor connections, specifically ensuring they are free of corrosion or damage, aids in maintaining accurate readings, preventing misleading information to the PCM. Ensuring the intake ducts remain clear of any blockages helps in sustaining the necessary airflow for cold starts, significantly reducing the likelihood of encountering idle speed issues. Adopting these preventive measures promotes engine longevity and improves overall vehicle performance. In conclusion, understanding DTC P050D, which indicates a cold start idle speed problem, is vital for maintaining the performance of the Honda Pilot. Proper troubleshooting steps, ranging from verifying sensor performance to checking air intake components, are crucial in resolving the issue effectively. Each step taken can directly influence the vehicle's drivability, particularly in cold start conditions. Successful completion of these troubleshooting steps not only aids in addressing the current error, but also builds a foundation for implementing preventive maintenance practices. By prioritizing regular inspections and prompt repairs, vehicle owners can enhance engine reliability and overall performance, ensuring that their Honda Pilot remains in optimal condition for years to come. Please like and subscribe to the channel. See you next time.